Hello, my name is Colin. I'm with Go Solar. This is going to be an inverter walkthrough. We're just going to go over some of the basic components of your inverter, as well as a few extra outside pieces that correlate to your system and its functionality. So we'll start with the inverter, we'll go into the secure power supply, and then we'll go into the rapid shutdown switch. So if we look on the upper left side of the inverter, you'll notice your solar DC disconnect. So this is essentially a breaker between your inverter and the solar array or arrays that you have. You'll notice when it's on, you'll have a 1 right here. It's just short for binary. And this circular dial will be in a vertical position. If we turn that off, it's counterclockwise. You'll notice that's a 0. And of course that will be parallel or horizontal. Same thing when we turn that back on. Will come up, that'll be vertical, you'll notice the 1. So that is how you operate your solar DC disconnect. So we'll talk about your lights on your inverter faceplate. You will notice you have 3 capsule shaped lights. We'll start from left to work our way to the right. This first one will flash green or pulse green. More importantly, you'll notice that fade in and fade out. That means you are producing solar electricity and able to backfeed that to the grid. You will see that every day, but it is important to keep in mind that that will go off at night. Obviously, when no sun is hitting your panels, you will not produce anything. So at nighttime, you see that off, do not worry. The next light, that's an event light. So that light will typically come on if there's some kind of an issue with your system. However, the only exception to that is if your power is out, that light will come on, just basically stating that it has or senses a disconnection from the grid. So if you see that, your power is out, do not worry about that so long as that light goes off once your power is restored. And that may take a couple minutes once your power comes back. Other than that, that light should always be off. The blue light over here, this is a web connectivity light. It will almost always be solid, but periodically it will flash. The flashing means the CPU is updating, so do not worry about that. And this light will be on 24 hours a day or so long as your internet is on and this is connected to it. Okay, so as you're looking at your inverter, off to the right of your lights, you'll notice a little display here. This will be dark, but when you knock on it, it will wake it up. And you'll begin to see different displays at this point. The first is your power display. So P is short for power, and this is your power or your production in watts at any given time. So this is a live value, and it will frequently alter depending on the sunlight intensity on your panels. Beneath that is E total. That's the energy and AC output from this inverter since it's been turned on. And that will just continue to add over time in kilowatt hours. As we go through to some of the screens, we will bypass a few as they are not relevant to production or usually for any other consumer reason, but we will stick to what is relevant to production as well as monitoring. So we'll go through here. As you knock, additionally, once waking it up, that will cause it to cycle through the screen. This is a software package in UL code. One of the screens that you probably won't reference, but it's more for us. SCR, that's your serial number specific to the inverter. If you wish to reference that, you can find that on the display. As we begin to go through, we'll go through some of these that you don't need to know necessarily. They're firmware packages. SCOM, this is one you can reference. If you do hardwire an Ethernet cord to your inverter for monitoring, you will see one of these with a corresponding connection name. So you'll notice the screen starts to auto cycle. That is one of the features of this. From here, SSID, that is your Wi-Fi signal. If we connect your inverter via Wi-Fi to monitoring. Another screen that you probably won't reference here, but we'll go through. These you will. So these being string inverters, we are able to see each string input. So DC A and B, those are just individual inputs in the inverter. So you can see live voltages and amps that correspond to the input. DCC typically will be blank as we have to install a rapid shutdown box that only has 2 outputs. So even if you have more than 1 string, you should almost never have more than 2 inputs into your inverter. So DCC will always be 0. The AC12, that's your grid connection. So roughly 240 volts to the grid, and then the amps that are the rate that you're backfeeding. From there, it will go back to the home screen, which will display your live power at any given point. At this point, we'll talk about your rapid shutdown disconnect. So all this is a switch that disconnects your solar array or arrays at the source. So this is not a switch that you will in any case actually operate. That's just something that's there for firemen. One of the things you'll notice is that there comes a key with your rapid shutdown disconnect. All this key is used for is to reconnect it in the event of an accident hit. So for example, if you have kids, they may hit the switch. I've even seen a landscaper pile up bags that then hit one of these switches, and they do mechanically lock in, and that is what the key is required for, to then unlock that and reconnect your system. But under any given other time, you will not operate this, and you may store this key anywhere you please. That's totally up to you. So from here, we'll talk about why you have one. So first off, it's law. Obviously, that's important, but the reason behind that is that solar panels, when they are hit by sun or when they're hit by light, they do produce a power or an electric current. So there's no real way to turn that off. So what we do is we install a rapid shutdown box beneath each of your arrays. And what that does is it disconnects when we hit this switch. So in the event of an emergency, let's say it's daytime, you had a fire, and the firemen needed to break through the roof to get to you. Every inch of that wire between the panels and the inverter, if every switch is off, is still live. So what this does is it disconnects it at the source and de-energizes all of those conductors between the array and the inverter, which obviously allows for the firemen to safely break through those if need be to get to you guys for a rescue. So let's say that your power goes out. You also may have noticed that you have one of these boxes installed near your inverter. What this is it's called a secure power supply. So if the grid goes out and it's daytime, so your solar is able to produce, you are able to utilize this outlet as it will provide solar electricity directly from the array. So what would happen, let's say your power is out, you'll notice at this point our power will drop down to 0. So you say, okay, well I want to access this outlet. So the first step to doing that is we'll open it. You will have a switch under here that you'll turn on. After we turn that on, we will have to wait about a minute. So that process is it's basically switching, doing relay switches to then provide power to this outlet. You also notice on the display, this will change. You'll see an SPS mode active, and your power value will now be blank. So the power values on here no longer represent production, but they represent consumption. So whatever you're pulling from that outlet will show the load value in watts of what you're actually pulling. So at this point, we'll come down, we'll take a look at the actual outlet. You'll notice that there is a little black box here that's an LED. Once that flashes red, you will press the reset button, and that will make this live. So at that point, this is now lit green, and you're able to actually pull about 1500 watts from this outlet during your power outage. So that is how you operate this. You can plug, obviously, 2 outlets here. But if you do exceed 1500 watts, it may trip if you're pulling more than it does provide. So do keep that in mind. As you'll see here, the power is in 0 because we're not pulling anything from the outlet. Another thing to note, once your power is restored, you do then want to turn that switch back to the off position, and that will allow that power then to be diverted back to the grid. And so we are once again in this display, we're just mocking a power outage. So let's go ahead and mock the restoration of your power. We'll then reconnect this to the grid. So at this point, this is where you would wish to turn this switch back to the off position. And so that will allow this to then divert back to the grid and feeding power. It does take a few minutes to then divert back to that stance. So do allow that time. However, if it exceeds, say, 10 minutes, do give us a call. We will walk you through a troubleshooting way to see what's going on with your system. And so as you see, now we are waiting for the actual inverter to then begin diverting back to the grid. Do keep in mind, once again, this can take time. Just sit here, watch it, make sure it is restored. Once again, if you do have an issue, please call us. Things to look for, this green light right now is flashing. We haven't reconnected to the grid internally in the inverter, but you will want to see this then begin pulsing like we saw earlier. As well as when you go through your display, just check out some of your numbers. So when you look at your grid, when you look at your strings here, you'll notice our voltages are present. So we are producing, but we're not flowing. And then same thing with our power. We are at 0 watts right now, but continue to watch and you will ultimately see this restored. So I do want to illustrate startup procedure, but do keep in mind this procedure will vary depending on your system and your setup, as our points of interconnection may vary dramatically depending on the system. So I will show you what we have here, and it is kind of the basic concept of startup. So you do have a DC switch, which we went over up here, and we also have an AC disconnect here. And that's where it connects back to the grid. So wherever your AC disconnects are, you do want to make sure those are turned on. And it is totally arbitrary as to which one you turn on first. You will not damage the system depending on the order in which you start these. So for this case, we'll start the AC, and then we'll turn on our DC disconnect, allowing power to the inverter. You'll notice your lights do all come on, all 3 lights. accompanied by SMA solar technology on the display. So during startup, it may take a few minutes to sync up with the grid, obviously allow the power to come back. So do give that time on your initial startup. You'll also notice a few sounds coming from your inverter, which you may hear momentarily. There are relay switches going on as your inverter powers up. So you can hear those clicking now. You will hear a few of those during startup procedure. But after this is through, these lights will go off and your green light should begin pulsing, as that is your production light. If you do have solar, or excuse me, your solar monitoring setup, this light also will come on. It's your solid blue light, but your red light will go off. If for any other reason that light does not go off during proper startup procedure, please call us. We'll walk you through it and we'll do what we can to get things taken care of. So as we look here, you'll notice the screen will remain, but we'll give that time and things will come up and you'll start to begin seeing your power values, seeing your lights. So at this point, our system is on, it is running. You'll notice all three lights are off, but we do have our solar production light on. It is pulsing. Once again, do keep in mind that flashing is not what you want to see, but this fading is what you want to see. You are producing, you are backfeeding. Our screen is now active. We can knock on it. So let's go ahead and check some of our voltages, our amps, see if those are good. We'll scroll through here. And so we'll see here, each string, we do have live volts and amps, so we know we are producing powers from those inputs. We'll check our grid. We know we are backfeeding. We do have the voltage from the grid, so we know we're connected, we know we're backfeeding. And then our power value. So we know we're producing a power total, and this is up and running again. You also notice this blue light will come on. It takes a little bit more time than everything else, so do give that a few extra minutes to then reconnect. But once this is solid blue, you are reconnected. So you've noticed we've talked a lot about monitoring and this blue light. Let's say that you have your monitoring set up and you change your Wi-Fi information. What do you do? So much like a cell phone, much like a laptop, that actual login information is stored on your inverter, and if you change that Wi-Fi information, we do have to reassign it. So the first step is logging into the inverter, which can most easily be done by a cell phone or a smartphone, as it does emit a wireless signal you'll see on your scan window for your Wi-Fi on a cell phone. So we do need a password to get into that, which you can find on a label on the bottom right side of your inverter. You'll notice the WPA2 code at the bottom. Do not include WPA2 in your password, but it is just that series of letters and numbers that follow that. So that is the password to get directly into this inverter signal. So take note of that, and then once you're in your cell phone, you can enter that password and log into the inverter. Once you have your WPA2 password from the side of your inverter, when you log into your cell phone, you will notice when looking for a Wi-Fi signal, you'll find one that says SMA followed by a long number. That is the serial number of your inverter. So go ahead and enter that WPA2 passcode here and connect. That will allow you to connect to the inverter's signal. Once that connection is made, it will warn you there is no actual internet connection here. Do not be worried about that, as that is not a source of internet. So now that we're connected, we'll move on. Back out, open a browser. And so you'll notice in the URL, you want to put the IP address 192.168.12.3. Once that is entered, you will get a warning that your connection is not private, it's not safe, do not worry about this. Advance through that, and then select the proceed to that particular IP address. As it will warn you it's unsafe, do not worry. At this point, we will come to the SMA login. So this is our second login. You will select the user group, installer, and your password. If you've had monitoring set up by us, it will be GoSolar1, capital G, 0, capital S, 0, LAR, number 1. Go ahead and enter that in. And then press the login button. At this point, you're inside the inverter. You can actually see what's going on. You have your device status, current power, that's the live value you see on the display, daily yields, feed-in management, and even a graph that will show you what's going on today. So your normal monitoring that you see on your app is obviously a little more refined than this, but this is just the view from inside your inverter. So at this point, let's say you want to update your Wi-Fi information as you change your internet service provider or your password for your Wi-Fi. You'll go up to this top right tab, has three little horizontal bars. You'll go down to User Settings, and then you'll go to Start the Installation Assistant. From here, it'll bring up a window. You see in this case, it's our Wi-Fi, we are connected, the status is okay. But in your case, if you were reconfiguring it, you would go to WLAN, which is your wireless, and then you would go down here, much like on a cell phone or a laptop, and see what your inverter sees in its proximity or in its range. So you would select whatever signal that you wish to connect to, your new name, whatever it may be, but you'll press the gear beside that signal. When you do, a little tab will open, WLAN settings, press on that. This is where you will enter in your new password. Once you have done that, press the Connect to WLAN button, and then scroll back up here. And you will notice that this will be, it should say connection establishment, ... That just means it is working on your connection from there. But once you see your green check mark and an OK, you know you are reconnected. And then from there, you can exit the app by pressing Save and Next. Through every screen, do not worry about altering any of these. Just press through until you get back to your home. And from there, you should have your Wi-Fi reconnected and your monitoring should be restored. So another question commonly asked, do I need to maintain my panels? Typically not. These panels, once it rains, it typically cleans itself. However, if there's some reason that you're getting a lot of dirt or something else that's building up on it, you can spray these with water with a hose. We do recommend, however, that you spray them in the early morning, as it has allowed time for these to cool. If you do spray these in midday time, particularly out here during the summer, you're going to cause a big temperature drop as these panels get really hot, and that is not good for the panels. So if you do wish to spray these off, only do it with water. We do not recommend you do it with soap, as that can leave a residue on here. Or if you have a squeegee, that's another good method, as well as if you feel comfortable getting on your roof, wiping some particular spot off that may have gotten on there, you may do so. But just to keep in mind, just use warm water, do not use soap, and obviously if you do spray these off with a hose, do it in the early morning to prevent damage to your panels.